Okay, you gotta draw your own picture according to the context of the story. Story number 1. To illuminate the entrance of an apartment building, a nightlight is mounted on a 6.6 meter pole. So we got a pole with some lights. Dun, dun, dun. The base of the pole is 24 meters from the entrance of an apartment building. Alright, so we got some apartment building right here. So here's the entrance, there's the door. So the base of the pole is 24 meters from the entrance, so that space is 24. Find the angle of depression from the light. Now light, its line of sight is going to be horizontal. But if it is going to lower to look at the door, the angle of depression is this. Okay, the pole is 6.6 tall. So your angle of depression is going to be the same as the angle of elevation. So this is what we're after right here. So if I'm going to mark it up from here, that piece is the opposite, that piece is the hypotenuse, that piece is the adjacent. So the trig I'm going to use the 6.6 with the 24. The trig is tangent. So the tangent, tangent, oh man, my board's not working. Okay, the tangent from that angle, I don't know what it is, angle theta equals 6.6 over 24. So solve for theta. I've got the fraction, so I need to undo the trig. So I'm going to inverse the tangent there, inverse the tangent there. So the inverse tangent of, now I gotta go grab a calculator. Okay, so typing it on the calculator, inverse tangent of 6.6 divided by 24, that means that angle is 15.376 degrees. Okay, story number 2. A child holds, I think we did this on the midterm. A child holds the end of a kite string 36 inches above the ground. So you got a kid, he's holding a kite string. The kite string is taut, string is nice and tight, and it makes a 68-degree angle with the ground. Okay, so from here to the ground is 36 inches, and he is gonna make an angle that is 68 degrees. And now, how high off the ground is the kite? If 540 inches of string, so here's the string, so 540 inches of string, so I'm going to go to the end of the string, and if I go all the way down to the ground, I know this much is 36, so I need to find this much. So I'm going to mark it from that 68. If I mark it from the 68, that's opposite, that's hypotenuse. So the trig we need that uses opposite and hypotenuse is sine. So the sine from that 68 equals opposite over hypotenuse. And now I have the angle, but I don't have the fraction, so I'm going to solve for x. So undo the divide 540. So times this by 540 times this by 540. So 540 times the sine of 68. 540 times the sine of 68. And that means this is 500.679. Plus I gotta add the 36. So 536.679. Okay, now we gotta find the measure of angle B. Angle B. Gotta make a triangle. This triangle, the base would be 3 and the height would be 4. And we know it's a 3, 4, 5 right triangle. So B, I'm going to use opposite and adjacent. So if I know that the tangent from angle B is the fraction of 4 over 3. That fraction only belongs to one angle. So let's undo the trig. Let's inverse the tangent. So inverse tangent right there. Inverse tangent of 4/3 will give me how many degrees it is. So inverse tangent of 4/3. That angle is 53.13 degrees. Question number 7. Excellent question. You got a circle with a diameter of 10 inches, and it's going to divide it into 6 equal sectors. So, whoops. A sector is like a slice of pizza. That is a sector. So we got 6 slices in the circle. The diameter is 10. That means that's 5. That's 5. All these radii are 5. Okay, the perimeter of each sector. So the perimeter is, if you choose a slice, then you walk around the perimeter. You walk 5 there. How far do you walk there? You walk 5 there. So the perimeter is going to be 5 plus 5 plus the arc length. That gives the Lenny Eakins. The arc length is, we need to know the circumference. So the whole circumference, I think she just swore too. She did. Let's have a testimonial. Did she swear?
Yes, she did. I did. Lady Aiken swore.
Alright. Now, so the circumference is pi times diameter. Pi times diameter is going to be 10 pi. So that means this. All the way around the circle, the circumference is 10 pi. So, we're going to divide it by 6. Because each of these 6 slices contribute to the 10 pi. So if we do 10 pi divided by 6, that does not divide very well. 10 pi divided by 6, simplify that. So your arc length is going to be 5 pi divided by 2. So my final answer is 5 plus 5. I've got 10 plus, I got like 5 pi divided by 2. That is the perimeter of that sector. Okay, more story problems. To calculate the height of a building, Joel walked 200 feet from the base of a building. So we got some building. And we got Joel. Dunk. So he's 200 feet away from the building. He used an inclinometer to measure the angle from his eyeball. So his eyeball right here to the top of the building. So the top of the building to his eyeball usually looks this way. That's his original line of sight. So that is an angle of elevation from where he normally looks if he looks up to the top of the building. So that's a 76 degree. Okay, so there's your triangle right there. And let's see, his eye level is 6 feet tall. So from his eyes to the ground, that's 6 feet. And we're going to find how tall the building is. So we need this piece. So your triangle, the base from there to his eye is still 200. So the trig we're going to use is tangent. So if we mark it from that 76, this piece is the opposite. This piece is the hypotenuse. This piece is the adjacent. So I'm going to do tangent from that 76, and it equals opposite over adjacent. So times by 200 times by 200. 200 times the tangent of 76 is 802.156. Plus I gotta add the 6 feet. So if you add the 6 feet, then it's gonna be 808.156 feet. Okay, now two bike ramps each cover a horizontal distance of 8 feet. So bike ramp number 1, Pochin, covers 8 feet. Bike ramp number 2 covers 8 feet. One ramp has a 20-degree angle of elevation, so that's 20 degrees. One ramp is steeper, it's got a 35-degree angle of elevation. Which ramp is taller and by how much? So if we drop and make a 90, if we drop and make a 90, we need how tall it is. And we need to find the difference between the heights. So the one that's opened up at a steeper degree is going to be taller. So this one's going to be taller. But we got to figure out by how much. So the trig is still, it's always tangent, 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 tangent. So we go from here, that's opposite over hypotenuse, or opposite over adjacent. So tangent from the 20 equals opposite over adjacent. Tangent from the 35 equals opposite over adjacent. So times them both by 8. So I'm going to go 8 times the tangent of 20. I'm going to go 8 times the tangent of 35. So this one is the short one, and it is 2.91176 feet tall, and this one is the tall one, and it is 5.60166 tall. So if I subtract them, if I do the big one minus the small one, the difference is, it is 2.68989 taller. Now, you need to find the sine of theta if the cosine of theta is 3/5. So you draw your own triangle. I make a 90, and you can put theta wherever you want. If I put theta there, this piece is the opposite piece, this piece is the adjacent piece, and this piece is the hypotenuse. So, okay, they give you this. They give you the cosine. Cosine, the fraction for cosine, the cosine compares the adjacent piece to the hypotenuse. So the adjacent piece is going to be 3, and the hypotenuse is going to be 5, and this is a Pythagorean triple, 3, 4, 5, so this opposite's got to be 4. And they want the sine, so the sine wants you to compare the opposite over the hypotenuse. So we are going to give them 4/5, and that is the sine from that same angle. Okay, the same idea. They give you the sine. The sine is opposite over hypotenuse. So if I put, doesn't matter where you put theta, don't put theta on the 90. So if I put theta there this time, then the opposite is 7, and the hypotenuse is 25. And they want the tangent, and the ratio for tangent is opposite over adjacent. And that is this, what I need to find. And this, I think, is also a Pythagorean triple, but it's not as familiar as the 3, 4, 5, so let's find it. So I'm going to go 7 squared plus just a squared plus b squared is c squared. 7 squared plus x squared equals 25 squared. So 25 squared, how much is that? Uh-oh. Okay, so we're going to change that to a 49. That stays x squared, and this 25 squared is 625. So now minus the 49, minus the 49. So we got x squared equals 625 minus the 49, 576. Now undo the square, so square root, square root of 576. It is 24. So now the ratio, we're going to do tangent. So we're going to put opposite on top, adjacent on bottom, 7 over 24. Easy cheesy. Okay, now circles. You gotta find the measure of angle GHI. So GHI, that's this angle right here. This angle is related to this arc. So if I can find the arc, I'm in business. There's a couple ways to find the arc. These two are a linear pair, so they make 180. So if I do 180 minus 96, I am left with 84. So if this is 84 degrees, this arc is 84 degrees. Because the central angle and the arc always measure the same. So that's 84, that's 84. That means my angle here from the circle is going to be 84 divided by 2. It's always half of it. So this is going to be 42 degrees. Okay, now the next one, you got to write an equation for a circle. The equation for a circle, you need to know the center. You need to know the h and the k, and you need to know the r. If you know the center and the radius, then it is x minus h squared plus y minus k squared equals r squared. So they give you x squared minus 10y plus y squared plus 8x plus 3 equals negative 2. So you got to rearrange the pieces a little bit. So I'm going to go x squared plus 8x, and I'm going to go y squared minus 10y, and I'm going to take the 3 over here, because that's going to hang out with my radius. So minus 3 equals minus 5. Okay, now you got to use a little manipulation, because you need to make it look like a perfect square. This is a perfect square, and right now this is not a perfect square, so you need to complete the square. So I'm going to add my own number here to complete this square. If I add a 16, 16 is the number I want, because if it's 8x squared plus 8x plus 16, then I can factor that, and it factors to a perfect square. X plus 4 times x plus 4, which is x plus 4 squared. So if I add a 16 on this side, over here I need to add a 16. What you do to one side, you got to do to the other. And your y's, the number I want is a 25. So you look at your b and you cut it in half, and this is 5 plus 5, so this is 5 times 5, so that's the number I want, the 25. And if I choose 25, then it factors to this, y minus 5 squared. So if I add a 25 on this side, I gotta add a 25 on this side. And if I do 25 minus 5, that's 20 plus 16, that is 36. So now you got it looking like an equation in standard form. So when it looks like this, you can find the h. Your h, your k, and your r. Your h is going to be a negative 4, your k is going to be a positive 5, and your r is going to be 6. So go left 4, up 5, that's your center, and then radius of 6 from there. So go 6 in all directions, and you got a circle. Alright. More circles. So here we go. You need to find GJI. You need to find this angle right here. Okay, now this angle is 48. If I double it, 48 and 48 is 96. That's this arc. And I know that is my semicircle, so I know this arc is 180. Okay, so now in a circle we gotta have 360. So if we're using 180 on the bottom, this top half also has to be 180. So if I do 180 minus 96, you end up, this gotta be 84. So this has to also be 84. Because if you measure from the central angle is always the same as the measure of the arc. Okay, now this one, E to D to F. So you need this right here. This angle makes this arc. So if I can find out this arc, then I can find out that angle. So this arc right here is 70 degrees, and this arc right here is 143. So this arc has to be 360 minus 70 minus 143. 360 minus 70 minus 143. So this has got to be 147. So this has got to be 147. And this has to be 147 cut in half. Which is an odd. So it's going to be 73 and a half. Okay, now we give you some circles. You've got to find the H, the K, and the R, which is pretty slick, pretty easy. So this H, if you start at 0, 0, I'm going to go over 4. The K is down 3. And the radius is 1, 2, 3. Radius is 4. So then your equation is going to be x minus h squared plus y minus k squared, and change that to a plus, equals r squared. And you could simplify that to be a 16. Circle number 2, your h, your k, and your r. Your h, to get to this dot, your h, you don't go left or right. So h is a 0. K, you go up 3. And your radius is 3. So then it's going to be x minus 0 squared plus y minus 3 squared equals 3 squared. And if you ever have x, if you ever got 0, just write that as x squared plus y minus 3 squared equals 9. Okay, now they're going to give you a picture. You need to select the inscribed angles in the figure by clicking the number of the angle. So I'm not really worried about this. This is the one that we want. So all these inscribed angles. This is an inscribed angle. They're all inscribed. Okay. So 2 is an inscribed angle. Check. And 4 is an inscribed angle. Check. So we got 2 and we got 4. 9 is inscribed, so that means this. All 3 of its points touch the circumference of a circle. 10 is an inscribed angle. So 2, 4, 9, 10. I think that might be it. 8 is not, because look at 8. 8, the center of the circle, so does not touch the circumference. So it's only partially, only the end points, not the vertex. So, I think only those 4 are inscribed. Now, part B. Place one number in each box to show 3 pairs of congruent numbers. So you're going to drop a 2 there. Angle 2. Because angle 2 makes this arc right here. So angle 2 makes that arc. But so does angle 4. Angle 4 makes the same arc. Angle 4 starts at a totally different spot on the circle, but it ends at the exact same spot as angle 2. So it makes the same arc. So 2 and 4 are good. And so are your other inscribed angles, 9 and 10. So 9 ends there, and it ends there. So 9 makes that arc. And 10 starts at a different spot, but it ends there. It ends at the same. So 9 and 10 are the same. And then we must have one more pair of congruent angles. And they are, actually we got a few. All your vertical angles are going to be congruent. So angle 5 and 7 are congruent because they're vertical angles. And 5 and 6 are a linear pair. So if you knew 5 was like 100, then you would know 6 is 80 because they're a linear pair. And then 6 and 7 are a linear pair, so you'd know 7 is 100 and 8 is 80. So you could do 5 and 7, or you could do 6 and 8. Any vertical pair are going to be congruent. Okay, now we did this on the midterm review. We got triangle ABC. C is 90. And you need to drag and drop some trig that create an equal statement. So if I copy and paste this triangle right here, and I say that's ABC, and let's make it a 3, 4, 5. So we're going to go 3, 4, 5. If I drag and drop cosine from A, so if I put cosine A there, now cosine from A, cosine is adjacent over hypotenuse, so it is 3/5. And this triangle over here, if I'm going from B to get that same fraction, to get 3/5, I need to do opposite over hypotenuse. So that would be the sine from B. So drag and drop sine B there. So if you are going from A and B, which are supplementary angles, so this is 90, so A plus B add and give you 90, so they're complementary angles, not supplementary angles. So they add together and give you 90. The trig from 1, if I do the cosine from one angle, is going to be the exact same as the sine from its complement. And that is always true. So if I drag and drop cosine B here, if we put cosine B there, that means I'm looking from the B. So cosine of B would give me, cosine from the B gives 4/5. And now I'm going to look up here, I'm going to look from A. To get the same 4/5, I got to go opposite over hypotenuse. So that'd be the sine from A gives you opposite. It gives you the exact same fraction, 4/5, 4/5. So sine from one angle is the same as cosine from its complement. Okay, the bottom one. The equation of a circle is shown. If we've got x minus 2 squared plus y plus 3 squared is 9, your circle is going to be like right here. Your h is 2, your k is a negative 3, and your r is 3. So that means I'm going to go over 2, down 3, and your radius is 3. So something like that. So now let's say we translate it. We're going to take it 3 units up. So I'm going to go up. Now it was down 3, so I'm going to go back up 3. Dunk, dunk, dunk. So that takes me back to the x-axis. Then we're going to go 2 units left. and I was 2 units to the right, so it's going to take you back to the origin, back to 0, 0. Then you're going to dilate by a factor of 2, so its radius is 3. So the new radius, I'm going to times it, I'm going to double it. If you dilate by a factor of 2, you're going to double it. So your new radius is going to be 6. So my h is 0, my k is 0, and my radius is 6. So that's going to be x squared plus y squared equals 36. This is the equation that is translated 3 units up, 2 units left from that one, and then blown up by a factor of 2. Okay, and last page. So we got triangle A, B, C. That is a diameter, so that means this is 180, so that means that is 90. Okay, it is given CD is the same as BC, and BC is 5, so CD is 5, and AD is also 5, because AD and CD are both a radius. And it wants to know this. What is the measure of AB? How long is AB? So you got a triangle, you got a 90 triangle. That's 10 by 5, and that's a 90. And we can actually do this. You can do Pythagorean theorem, a squared plus b squared c squared. Or you can see that it's a 30, 60, 90. Because if I flip the other half, it looks like this. I should have drawn it better. Okay, there we go. That's 5, that's 10, that's 90. And you've done enough, so that would be 10, and that would be 5. So this is 5 square roots of 3. So you use half of an equilateral triangle, 10 by 10 by 10. Or you can do Pythagorean theorem and get the same thing. Get 5 square roots of 3 when you're done. Okay, last problem. Drag and drop digits in the boxes. So if you drag and drop 4 there, this angle from the circle is 4 degrees, then you would have to drag and drop an 8 there. So your arc measure is always half, or is always doubled the measure of the angle from the center, or from the circle. And that is it.